Hello, welcome to this week's problem of the week. For this problem, we're given a cubic polynomial f of x, whose value is equal to x cubed plus x plus 1, and also given a polynomial g of x, whose roots are the squared roots of f of x, and whose value at 0 is equal to -1. So given this information, we have to find g of 9. So the first thing we do is we write f of x out in root form. So as you can see, what we did here is we wrote f of x as equal to x minus a times x minus b times x minus c. And we solved for 0 to find that the value of abc is equal to -1. And so now what we do is, now that we have the roots of f of x, which are unknown variables, a, b, and c, we can write g of x, where we square the roots of f of x. So we'll have x minus a squared times x minus b squared and x minus c squared as the roots. And so as you can see, we've written g of x as k times x minus a squared times x minus b squared times x minus c squared, where k is some multiplier. So what we do now is we figure out what k is equal to. So to figure out what k is, we've solved for g of 0. We find that it's equal to -k times a squared times b squared times c squared. And a squared, b squared, c squared can be written as abc all squared. So we find that -k abc squared is equal to -1. And we know that, or since they're negative on both sides, we can multiply both sides by -1. And since abc is equal to -1, abc squared will equal 1. So we can say that k is equal to 1, and we can rewrite g of x. And so we now have g of x equal to this nicer expression without k as an unknown. And so we can see each of these expressions is in the form a squared minus b squared. And to make it look a little bit nicer and more or easier to factor, we're going to plug in x squared in g of x and see what we get. So doing that quickly, we see that g of x squared is equal to x squared minus a squared times x squared minus b squared times x squared minus c squared. So what we're going to do is just factor all of these into the form x plus a, x minus a, and then we're going to rearrange them so they're nicer to look at. So what we have now is we factored all of these out, and we just changed the order of them around a little bit. And so we see that g of x squared is equal to x minus a times x minus b times x minus c times x plus a times x plus b times x plus c. So what we have now, the first three terms are x minus a, x minus b, x minus c. And as you can see, that's equal to the original value of f of x that we found. So we can plug that in. And now we're left with g of x squared equal to f of x times x plus a times x plus b times x plus c. So we want to get this into form minus a minus b minus c for all these. So the way to do that is to take a negative out of each of them. So what we did here is we just pulled a -1 out of the last three terms. We find that g of x squared equal to f of x times -1 cubed, negative x minus a, times negative x minus b, times negative x minus c. So for the -1 cubed, we'll simplify that to just equal -1. And for these terms, you can see that it's close to f of x, but instead of x, a negative x is the leading term. So that just means that these last three terms are equal to f of -x. So now we'll plug that in and simplify -1 cubed. And now we have a simpler or simplified expression of g of x squared, where it's equal to negative f of x times f of -x. And so now we know we have to solve for g of 9, but we know that 9 is equal to 3 squared. So now all we have to do is plug in 3 and -3 into f of x and solve. So as you can see, we took g of 9 equal to g of 3 squared, which equals negative f of 3 times f of -3. And so you plug 3, -3 into the original polynomial here, and then it's plug and chug, and we find that g of 9 is equal to 899. Thank you so much for watching this video. Be sure to subscribe to our YouTube channel, follow us on Facebook and Twitter, and check out our website, centerofmath.org. Thank you.